exercise number 4C. Here we have different formulas and we have discussed these formulas in class. I hope you have understand it well. So let us look once again. This is annuity, and then this is type of annuity. This is ordinary or regular annuity, and this is annuity due or immediate annuity. Then this is the future value of formula, and this is the ordinary future value, and this is annuity immediate of formula. Then we have present values in the right hand side column, and I have distributed this ordinary present value in 4 columns, where I have left one blank. These 4 are one and the same thing, where you may have wondered why I have write V equal to A into P of Ni. V is actually present value, and A is this A, and P of Ni is this square bracket 1 plus I whole power n minus 1 divided by I into 1 plus I power n. So there is no confusion regarding this. And in the present value of annuity due, this is these formulas which we have already known. Now let us start our question. The question is, the present value of annuity of rupees 3000 for 15 years at 4.5% per annum compound interest is option number A, option number B, option number C, and option number D. First we collect the information from the given question. Here annuity A, as we know, it is given by A is given by rupees 3000. Then he says a time period of 15 years, that is n is 15, and I is 4.5%, which is equal to 0.45. Then he says, what is the present value of annuity? So we will use here formula. First we have to think about which annuity he is talking about. Is this ordinary annuity, or is this immediate annuity or regular annuity? So let us see. When he is talking about a 3000 annuity giving a time duration of 15 years at rupees 15, so definitely he is talking about an ordinary annuity or regular annuity. Now we know the formula for the present value. First we recall that formula, what we have written by present value is equal to A into 1 plus I power n minus 1 divided by 1 plus I power n into I. Or you may have remember this formula like that: A into 1 plus I power n you may have remember this 1 minus 1 plus I power minus n divided by I. In simple, present value is equal to this, and you may have remember we have then named it as simple V. V is equal to this thing. So we will give it its values so that we will get the present values. A is 3000. Then we have 1 minus 1 plus 0.45, which is the value of I, and then we give minus, and n is 15 divided by 0.45. Now we have to simply calculate. We have to calculate 1 plus 0.45 over minus 15 times, or you may do it by 1.045 whole power minus 15 is equal to 1 divided by 1.045 powered by 15. That means this is same. First you have to calculate 1.045 15 times on the calculator simply by multiplying it 15 times, and then that number should be divided by 1. You will get the result. So when I did this, I found its values, which I will write. It is equal to 1 minus, when I this is equal to this value, then this is equal to 3000 into 10.7395 727, which is equivalent to 32218.63. 32218.63, that is our final value is 32218.63. that is present value of that amount is this thing. When we check the options, so we are near about to this option, but there is a little bit difference of rupees 4 about, so there is confusion to take this or not. For an approximation we can take this answer number B, but if we choose selectively most appropriate option he is saying, then appropriate can be D. So there is confusion B and D, so I hope there should be no confusion. So D is the correct choice to be taken. Question number 2. The amount of an annuity is certain of rupees 150 for 12 years at 3.5% per annum compound interest is. That is, he is talking about the future value of the amount, because he says annuity is a certain of rupees 150 for 12 years. So we have to calculate the future value. And what type of annuity is this? It is simply an ordinary annuity, or you may write it as A of NI, which is ordinary annuity. The formula for this is A into 1 plus I power n minus 1 divided by I. Since we are given A is 150, N is 12, and R is 3.5%, or I, which is equivalent to 0.035. So let us solve this. A is 150, 1 plus I is 1.035 powered by 12 minus 1 divided by 0.035, which is equal to 150 into 1.035 powered by 12 is 1.5110608657 then it is subtracted by minus 1 and it is 0.035. Now however we know 1 minus that thing is equal to 150 into 0.511068657 whole divided by 0.035, which is equivalent to 150 into this divided by this and multiplied by 150. So let us first solve. Divided by it by 1.035, it will be equal to 14.6 6019637, and this is equal to 2190.29. Therefore, the first option is 2190.28. I think this is the correct option. So this is the correct option.
Number 3. A loan of rupees 10,000 is to be paid back in 30 equal installments. The amount of each installment to cover the principal and at 4% per annum compound interest is. First of all, it says a loan of rupees 10,000 is to be paid back in 30 equal installments. So it is talking about ordinary annuity, or you can say regular annuity, ordinary or regular annuity. Number second, the present value V is given by rupees 10,000, and then n number of period is 30 and I is 0.04. Since these are given and it is talking about an ordinary annuity, now we will look at the formula. V is equal to A into P of Ni, where they have usual meanings. So I can write it, present value is equal to A into 1 plus I, or let us write that 1 minus 1 plus I power minus n divided by I. This is equivalent to, where we will give the values of present value is 10,000 is equal to A, which is to be find out 1 plus 1.04, that is 1.04 power 30 divided by 0.04. Then it is equivalent to, after solving this, it is equal to 10,000 is equal to A into, now here it is 1, here it was minus 1.04 powered by 30. After calculating this, it is the value of this is 0.3083186668, and it is divided by 0.04. So it can be written down by here. It is equal to 10,000 is equal to A into, we know it will be equal to 1.691681332 whole divided by 0.04. Further, when we divide by these two numbers on the right hand side, it will be equal to A into 17.2920333. The numbers are big, but we know it is all about the calculator we are doing. So it will be, we are left with A on the right hand side, and so I will write it like that, which is equal to A. After dividing 1000 by this number, it will be equal to 10017.292033, which is the value of A. Therefore, we were wrong in calculating this. The actual number is, after calculating this, A is equal to 578.5 0.30. Therefore 578.30. So we are near about this. I think option A is the correct answer. There maybe have been done some. Question number 4. A is 1200 and is 12 years. Rate of interest is 0.08. We have to find the present value. Since we know V is equal to A into 1 plus I power n minus 1 divided by I into 1 plus I power n. This and this formula is same because when we divide, so let us see that it will be A divided by I because this I have taken out. Then see 1 plus I power n divided by 1 plus I power n minus 1 divided by 1 plus I power n. It is same thing. So here I can write A divided by I into 1 minus 1 divided by 1 plus I power n. So the formula is same, there is nothing bother about that. Now we will use the formula and to find V. Since V is equal to A is 1200 divided by I is 0.08, we have to simply give the values 1 divided by 1 divided by 1 plus 0.08 powered by n is 12, so n is to be replaced by 12. Now after finding the its values, which is equal to 15,000 into 0.60288, when multiplied in both it is equal to 9043.30. Therefore option D is the correct option.
Question number 5. A is given rupees 100, N is 10, I is 5%. Find the future value of annuity. Using the formula, future value is equal to this thing. A divided by here it is actually I.
A is given
A divided by I,
rupees
1
N is
plus
10,
I
I is
power n
5%.
minus 1.
Find the
Future
value of
value is
future
equal
annuity
to.
using the formula N is given by. Since A is given by 100, N is 10, I is 0.05. After substituting the values, we get future value is equivalent to A divided by I. Here you should note this is I into 1 plus I power n minus 1. Therefore, we will substitute given values. It will be 100 divided by 0.05 and it will be equivalent to 1.05 powered by 10 minus 1. Then we have to find the values of these. 1.05 powered by 10 is equal to 1.6288946.268. Further it is subtracted by minus 1, which is further equal to 100 divided by 0.05. But remember, when you are solving this on calculator, you have to do it in a little bit, such that when you will calculate this value, you have to further at that time subtracted by this minus 1 and then divided by 0.05 and multiply by 100. So your calculation should be in brief period. Now here it will be equal to 0.6288946.268. Further, this is divided by 0.05. After dividing by 0.05, this will be equal to 12.5789, then it is 2536. Now the number is, which is approximately equal to 1258. Therefore Option A is the correct option.
Question number 6. If the amount of an annuity after 25 years at 5% per interest compound per annum compound interest is rupees 50,000, the annuity will be. Here the question is saying as the amount of an annuity after 25 years at 5% per annum compound interest is rupees 50,000. That means it is talking about the future value, that is rupees 50,000 is the future value of amount. Number second, we are asked what is the annuity. So the question, let us start the question. We are given future value, that is V is equal to rupees 50,000, I that is 0.05, and the time period N is 25. So let us begin our question. And important thing is that what type of annuity is here is discussing. Let us repeat the question. Annuity after 25 years at 5% per annum compound interest is rupees 50,000, the annuity will be. Here it is directly talking us about the ordinary annuity. Therefore, we know the formula of annuity of future value. When it is future value, it is equal to A, that is V is equal to A and I is equal to A into 1 plus I power n minus 1 divided by I. Then we will give the two values. V is 50,000, which is equal to, and we are being asked what is A, so A is to be find out. Then it will be 10.5 because 1 plus I is 1.05 and N is 25, then minus 1 divided by again 0.05, which is further equal to A. Here it is as it is 50,000. Now when we calculate 1.05 whole power 25, the value comes out 3.3863549 and here then we have minus 1 and this is subtracted by 0.05. Again this quantity 3 minus this and minus 1, it will be 2 point something. That means it will be 2.3863549,409. Further, when we divide 2 point by 0.05, so let us repeat this step. It will be like that. It should be divided by 0.05. After dividing 2 point this, it will be equal to, here it is 50,000 as it is, it will be equal to A into 47.7270988818. Therefore A is equal to 50,000 divided by 47.7270 so on, whose value is 1046.92. Therefore the correct option is option A. Question number 7. Given annuity of rupees 100 amounts to rupees 3173, at 4.5% per annum compound interest, the number of years will be. Here 3173 acts as a future value because the annuity is 100 amount and this is the rate of interest. First of all, given annuity of rupees 100 amount to means it sums up to this value at a rate of this. it sums up to this value at a rate of this. That is the final value, which is the future value is 3173. Now we are being asked the number of years will be. Let us solve this question. Here a is equal to 100 and v, that is a of ni. Sometimes we write it as a of ni, sometimes v. This is equal to 3137.12 and I is equal to after that we will use the formula of the annuity of ordinary type, which is a of ni, which is equal to v is equal to a into 1 plus I power n minus 1 divided by I. This v is given, it is 3137 is equal to 100 into 1.045 powered by n minus 1 divided by 0.045. Again we will write it as, so first we transfer 0.45 and 100 here, then it will be 0.045 divided by 100, because this has been transferred here and 100 there, which will be equal to 1.045 powered by n minus 1. Here it is actually 3.12, again here it is 12. So let us see what will be the result here. The left side will be equal to 1.411704. Here on right hand side there is 1. I will transfer it here, it will again sum up with this, so it will be 1.045 power n, which will be equal to 2.411704 is equal to 1.045. now we will see the value of n, either 25, 20 or 22 should satisfy this. If these three does not satisfy, then the option D is the correct answer. So we will check for what n these are to be satisfied. For n equal to 20, the equation satisfies. Therefore, the option B is the correct answer. Question number 8. A company borrows rupees 10,000 on condition to repay it with compound interest of 5% per annum by annual installments of 100,000 rupees each. The number of years by which the debit will be clear is. There are given options. Here, this question is directly when someone is taking a loan and the same condition applies. That means here the principal amount, you may have, it was 1000 rupees, or the same, either you say it is principal amount which was written by P, and present value is 10,000. Principal amount is 10,000, present value is 10,000, both are same. Then we have to pay it by installments, that is 1000 rupees each at rate of 5%. So let us see how to solve this question. In the given question, the present value or P, principal amount is 1000, and rate of interest is 5%, that is 0.05, and A is 1000 rupees. We are given only these three things. Now we have to find two things. Here we should know, first the question says the number of years, that is we are asked to find n. Before n find out, we should know what is the future value of the amount. Now to get the future value, we recall the formula A is equal to P into 1 plus I power n, which is the formula for compound interest when we are interested in finding the accumulated amount within a period of n years. Using this formula, we will get A equal to principal amount is 10,000 rupees. This is 1.1 plus 0.05 powered by n. So this is 10,000 into 1.05 powered by n. Now this is A, that is future value, or you can say accumulated amount. Again, now we come to our own formula. First, company borrows rupees 10,000 on a condition to repay it. So the question is directly related with ordinary annuity. Therefore, A of Ni, which we are using in the previous question, is again this is equal to A into 1 plus I power n minus 1 divided by I. I hope you will not be confused by this A and this A. This is accumulated amount, that is future value, but here it is annuity, because different formulas in different contexts. Now using the values in this, we have A as 1,000 rupees. Now this annuity, therefore A of Ni Ni is equal to 1,000 rupees, that is this 1,000 into 1.045, 0.5, so there was some mistake, 0.05 powered by n minus 1 divided by 0.05, which is equal to 1,000 divided by 0.05 into 1.05 power n minus 1, which will be equal to 20,000 into 1.05 power n minus 1. But remember, A of Ni is future value, that is we have to pay in total, and the same amount was recently founded by when we solved this equation, and this. Both are same, therefore comparing these two equations, we get, because this is the final value we have to pay, it implies 10,000 into 1.05 powered by n is equal to 20,000 into 1.05 powered by n minus 1. Now comparing these two, it implies 1.05 powered by n is equal to 20,000 divided by 10,000 is equal to 1.05 powered by n minus 1. Now here these 40 will cancel out, that will be 2. Now we will rewrite this as 1.05 powered by n equal to 2 times 1.05 powered by n minus 2, because this was multiplied by this. Now shifting 2 there and number powered by n on one side, so it will be 2 equal to 2 2 minus 1, that is 2 1.05 powered by n minus 1.05 powered by n. These are 2 times this 1 time, so it will be simply equal to 1.05 powered by n, which will be equal to, implies and equal to. Question number 9. Mr. X borrowed rupees 5120 at 12.1/2% per annum compound interest. At the end of 3 years, the money was repaid along with interest accrued. The amount of interest paid by him is, option 4 are given. Since in this question the amount taken is 5120, interest is 12.1/2%, which is 12.5%, which is 0.125. Therefore, and n is 3 years. Now the question is simple and direct. There is no concept of annuity in this question, and neither we are asked about to find out it. We are simply asked about to find the interest. We can use the previous formula directly, since we know a equal to p into 1 plus I power n. Because when we are able to find I, we can find compound interest by simply subtracting p from a. Therefore, a is equal to 5120 into 1 plus 0.125 powered by 3, which is equal to 5120 and 1.125 powered by 3. After simplifying these values, we get 7290. Therefore, a is equal to 7290. Now we know compound interest is equal to a minus p. A is 7290, p is the principal amount 5120. Therefore, it is 2170. Therefore, option B is the correct option.